Hello guys, welcome once more to another video on our YouTube channel. So in this video we are going to continue solving the physics section of the National Aptitude Examination into the first year of medical, pharmaceutical and odontostomatological training in Cameroon. That is the medical entrance examination. So this is physics 2017 question number 13. So the question reads, if the frequency of a harmonic oscillator doubles, by what factor does the maximum acceleration change? Okay, so first of all, I would like us to define what the maximum acceleration of a harmonic oscillator is. So a harmonic oscillator is basically an oscillator that undergoes simple harmonic motion. And if you're undergoing simple harmonic motion, by definition, your maximum acceleration will be defined by A equals omega squared r. Generally, your acceleration is negative omega squared r. Maximum, the negative sign just indicates that the acceleration is always opposite to the direction of motion. In fact, the acceleration is always pointing towards a fixed position, that is the fixed point. So when we talk about the maximum acceleration, we don't consider the negative sign. Okay, now omega here and r here have their own definitions. So omega is what we call the angular velocity, and it is given by 2 pi f, where f is a frequency and r is the amplitude. So since we have information about the frequency, then we can clearly write the maximum acceleration in terms of the frequency by replacing omega with 2 pi f. So the maximum acceleration becomes 2 pi f all squared times r, because it is omega squared r. Now if we expand 2 pi f all squared times r, we are going to have 4 pi squared f squared times r. So if you check the relationship between the maximum acceleration and the frequency, you realize that because 4 pi squared times r is a constant, it therefore means that your acceleration is basically equal to a constant times the square of the frequency. And with that said, we conclude that the acceleration is directly proportional to the square of the frequency. From here we can deduce the expected result, okay, because if the acceleration is directly proportional to the square of the frequency, it means that if the frequency doubles, the acceleration is going to quadruple, which means that we have to square the factor attached to the frequency. But anyways, let us analyze it theoretically. So if the frequency doubles, it means that the new frequency is 2 times the original frequency. First of all, the new acceleration is 4 pi squared times the new frequency squared times r. This r is the maximum displacement, that is the amplitude. It is constant. So I'm going to replace my new frequency with 2 times the original frequency. Doing that, we have 4 pi squared times 2f all squared times r. Now 2f all squared is 4f squared, but since I need to compare my result with the original acceleration, then I am going to rewrite everything here as 4 times 4 pi squared f squared times r. What I did was that I can just remove this 4 from this position and I multiply it with 4 pi squared f squared and r. Multiplication is commutative. A times b is equal to b times a. But we know that 4 pi squared times f squared times r is the original maximum acceleration with frequency f and amplitude r. So it therefore means that we have that the new acceleration is 4 times the original acceleration. So in conclusion, the maximum acceleration will change by a factor of 4. That is, it is going to quadruple. And if you look at the options, the correct answer is option C. Alright, so see you guys in the next video.